any subject for that matter. Okay? Now, the problem ఏంటంటే ఈ ఒక్క ప్రాబ్లం చేయడానికి there are two problems, there are three అనుకోండి. You have taken 1 hour. Remember, examination లో you don't get more than 15 minutes to do this one. So how do you accelerate? So you must be thorough with the fundamentals. ఎక్కడ ఏ ఈక్వేషన్ టక తెలియాలి మనకు. So you must know what is the correct numbers with the final state ఏంటి, initial state ఏంటి, అన్ని ఒక్కొక్కటి అర్థం చేసుకోవాలి మనం. So these are the things. So can you please do the final one for polytropic process? If you go straight away, ఇక్కడ నుంచి straight away from here to here, ఎంత వస్తుంది? Can you all do it? Okay, good, thanks. Okay, now I have to switch the topic. So we'll go to radiation now. Take the other notes. We saw that when radiation is coming up to an object, when it is transparent. For example, I gave you the example of glass, and why we use glass on top of the solar collector, and why we use glasses in windows and all these places. Now, why we use glass here? The daytime we want only the light to come, but we don't want the heat to come inside the room. And the other glass would heat problem. So you get a bright light, you don't need even the lights here. తర్వాత ఎందుకు గ్లాస్ నుంచి హీట్ లోపలికి రాదు? బికాస్ గ్లాస్ ఈజ్ ఒపేక్ టు ఇన్ఫ్రారెడ్ రేడియేషన్. ఓన్లీ విజిబుల్ రేడియేషన్ గ్లాస్ నుంచి వస్తుంది, ఒపేక్ ఇన్ఫ్రారెడ్ రేడియేషన్ లోపలికి రాదు. This is also one of the reasons why you put a glass cover on top of a solar collector, so that when the solar collector is heated, you don't want to collect all the energy, you don't want that to be radiated back to the atmosphere. So they put a glass cover so that it prevents the infrared, the heat from the solar collector going to the atmosphere. That's why we use a glass cover. There we saw what is the importance of using an opaque object. An opaque is something through which the radiation cannot be transmitted. For example, if you take this book, and this is opaque even to light also. I can't see. If I put a light, put across, I can't even see the light. But at the same time, if it is opaque to light, most probably it is opaque even to thermal radiation also. On the other hand, a glass is transparent to visible radiation and opaque to infrared radiation. So depending upon how much of radiation you want or you don't want, depending upon that, you decide what kind of a thickness of the material you want in order to prevent. So if you want a lot of radiation to come in, you make for example, glass, you make it as thin as possible. But at the same time, you don't put it too thin First, there is nothing wrong putting a thin glass here. Like what in case there is some kind of a cyclone or something like Ananthapuramu cyclone now and in other places the cyclone pressure comes and hits it, the glass will break. So in fact you would have seen that in US about 3 months back there was a big cyclone in Miami. You know, so many houses were wiped out. Most of the places people got injured because when the cyclone wind is about 150-200 kilometers an hour, it comes and hits on the glass. The pressure will actually break the glass, and the shattered glass actually flew all over the place, and people got injured. So it's one. Of course, in addition to that, all the rainwater came, wind and everything. There's so much of other damage coming in there. So in order to prevent it, you make sure that your glass is thick enough so that you can withstand this what they call the cyclonic wind pressures. That's of course civil engineers somebody చేస్తారు. మనం కెమికల్ ఇంజనీర్ మనం చేయక్కర్లేదు, మనం చెప్పాలి వాళ్ళకి. ఈ రేడియేషన్ కావాలంటే మనకి ఇంత మినిమం ఇంత దప్పం ఉండాలి. వాళ్ళు అంత దప్పం పెట్టి ఇంత దప్పంగానే పెడతారు వాళ్ళు. ఎందుకంటే దే వాంట్ టు మేక్ షూర్ దట్ గ్లాస్ పగలకుండా. బికాజ్ ఇప్పుడు ఏమైందంటే చాలా మంది ఇప్పుడు గ్లాస్ చాలా రేట్ ఎక్కువైపోయింది, పర్స్పెక్స్ పెడుతున్నారు. The perspex also is actually perspex is more or less glass. If you look at from a distance, you can't make out the difference. I told you what is perspex? It's called polyvinyl carbonate. So that's actually most of us we use that one. అది యూస్ చేసినప్పుడు ఒకే ప్రాబ్లం ఏమంటే ఈ పర్స్పెక్స్కి గ్లాస్కి ఏం డిఫరెన్స్? ఎందుకు మన ఇళ్లలో విండోస్లో పర్స్పెక్స్ గ్లాస్ పెట్టాలి? దిస్ ఎనివన్ హ్యావ్ అన్ ఆన్సర్. మీ ఇంట్లోనే ఏం పెట్టారు? పర్స్పెక్స్ పెట్టారా, గ్లాస్ పెట్టారా? మీ ఇంట్లో విండోస్ గ్లాస్ పెట్టారు కదా. ఎందుకు పర్స్పెక్స్ ఇస్ నాట్ చీపర్? ఎందుకు పెట్టారు పర్స్పెక్స్? రేట్ తక్కువ. పర్స్పెక్స్ ఇస్ చీపర్ దాన్ గ్లాస్. ట్రాన్స్పోర్ట్ ఎవ్రీథింగ్ ఇస్ చీపర్. Okay, this is something not beyond radiation. Perspex ఏమవుతుందంటే over a period, because it's a chemical after all. Any chemical, when it is subject to UV radiation, it degrades. So perspex is something which is subject to UV radiation, it degrades over a period of time. Suddenly it becomes very brittle, and sometimes you will see cracks in perspex. So that comes because of UV degradation. అందువల్ల perspex యూస్ చేయాలి. Yes, because it's a chemical. Glass is inorganic material. Perspex is organic material. So most of the organic material, they are sensitive to UV radiation. Most of the inorganic materials are insensitive to radiation. That's beside the point, radiation. So we have seen what is the importance of having a solid, and by the way, you don't want to have a solid. For example, in winter, మనకి ఇక్కడ ప్రాబ్లం లేదు కానీ European countries, or for example in US, you would have seen in the news saying that northern parts of US and quite a few areas of Canada are suffering under severe what they call a snowstorm. అంటే బయట టెంపరేచర్ will be about almost -20, -30 degrees దాకా వెళ్తుంది. డిగ్రీ సెల్సియస్ అయింది అది వెళ్తుంది. అప్పుడు ఏం చేస్తారు? రూమ్ అంతా ఏం చేయాలి? కంఫర్టబుల్ రూమ్ హీట్ చేసుకోవాలి. స్పెండ్ నాట్ ఆఫ్ మనీ హీటింగ్ రూమ్. అక్కడ గ్లాస్ పెడతారు. ఎందుకు గ్లాస్ పెడతారంటే అవుట్ సైడ్ టెంపరేచర్ ఇస్ లో, ఈ గ్లాస్ నుంచి థర్మల్ రేడియేషన్ బయట పడుతుంది. That's again one purpose of having a glass window, so that your heated room this will become cold. Of course, still there will be some kind of a loss by conduction. That's only by glass conduction. As you know, glass has got a lower thermal conductivity. So that means the conduction will also be small. It won't be zero, it will be small. At the same time, what you are doing is you are trying to prevent the room heat from going to the ambient. So that's actually the purpose of having a glass in a construction material. But for the glass, for example, when you are driving a car, you use a glass there. There's many places where you use the glass in your day-to-day life. So this is actually about the solids which absorb or transmit radiation. In addition, can liquids and gases also do that one? They can, because if you go to a swimming pool, for example, you take a deep dive, still if you from the water you can still see the sun, correct? May not become, but still that means visible radiation again comes there, but again water is also opaque to infrared radiation. So it's also opaque. So similarly, that is about the liquids. There are several liquids also which are opaque to infrared radiation. That's what because we don't use them in normal practice to prevent or enhance radiation. But the next thing is the more important part of it, what is the absorption of radiation by the gases. Normally we see that most of the monoatomic and diatomic gases, which are they? Monoatomic gas, example it is argon and helium, neon, argon, krypton, xenon, radon, all the monoatomic gases. Diatomic gases ఏమో ఉన్నాయి? Nitrogen, oxygen, మిగిలినవన్నీ పీరియడ్ టేబుల్స్ అన్ని మిగిలినవన్నీ డయాబెటిక్ యాసిడ్ కదా అవన్నీ అదర్ అన్ని డయాటమికేనా దేశం అదే అదర్ దాన్ హీలియం నియాన్ ఆర్గాన్ క్రిప్టాన్ xenon and radon which are the other gases available in periodic table? Nitrogen, oxygen, fluorine, bromine liquid bromine iodine solid. So it's a gas ఎక్కువ లేవు periodic table లో ఒకటి ఏమిటి hydrogen, then you have got nitrogen, you got oxygen, chlorine and fluorine. ఐదు గ్యాస్ ఉన్నాయి, ఐదు అంతే. సో సింపుల్ కదా, మిగిలినవన్నీ ఏది లిక్విడ్స్ వస్తాయి. So what happens is this so-called diatomic gases, some of you must have just read from there. These are all transparent radiation. That is, they can get through the UV radiation or the infrared radiation is just get through. There is no problem at all. Where the problem comes is the tri and polyatomic gases, they have got ability to absorb radiation. So for example, CO2 is a three atoms. H2O is there. So CO2, methane, water vapor, even some of the refrigerants, they are all what we call as polyatomic gases. They have got absorption for atmospheric radiation. So in a way, it is actually good because if sun's radiation, calculation, sun radiation approximately the outer surface of the earth is about 1.4 kilowatts per 1.4 kilowatts per meter square. Radiation completely భూమి వచ్చిందంటే మనం ఎగిరిపోతాం. Okay, we all get burned out. But approximately, for example, if you take Ananthapuramu and a day like this, it is so bright and sunny, even at middle of the day, మనకి ఎంత radiation అంటే we don't get more than about 900 watts per meter square. బయట వచ్చిన 1400 ఎందుకు 800 తగ్గింది? కెన్ ఎనీవన్ ఆన్సర్ దట్ క్వశ్చన్? Ozone depletion it takes out only the UV part of it. Ozone depletion is one, but the main reason is the atmosphere low. There is a lot of this multi-atomic, tri and polyatomic gases like CO2, water vapor ఎక్కువగా ఉంటుంది atmosphere. So the thickness of atmosphere, as you know, the thickness of course on the ground level they are not almost atmospheric pressure. As you go to higher altitudes, the air becomes thinner. That's why they say if you go to Ladakh or any other places, they say first the moment you go back from the airport, don't keep on walking. You get too tired because oxygen content is less and the atmospheric pressure also is less. So you get used to acclimatize to the weather, then you go on further. అట్లా మీరు క్యాల్కులేట్ చేశారంటే ఫర్ ఎగ్జాంపుల్ at higher altitudes air becomes thinner but still there is air. And this approximately the thickness of air layer above the atmosphere runs to few tens of kilometers. ఈ tens of kilometers లో solar radiation వస్తున్నప్పుడు this radiation is absorbed by the earth. And very fortunately what happens is even these gases are transparent to UV. UV will get through but heat will not come through. We have seen in the solar radiation the 1.4 kilowatts per meter square over the entire spectrum. అందులో UV radiation వచ్చి చాలా తక్కువ. So UV మనకు వస్తుంది but infrared is actually rendered from there. That's actually a good for us. Okay? So otherwise the entire 1400 1.4 kilowatts వచ్చేది మనం అంతా will get burnt out. So God has created very nice atmosphere. Earth you have got air around that one. మీకు ఎంత హీట్ కావాలో అంత మాత్రం వస్తుంది అన్నట్టు. అది బాగుంది, అంత బాగుంది. కానీ ఎక్కడ ప్రాబ్లం వస్తుంది? The moment you turn on any of this TV channels, in fact there is one talk by one of my colleagues from IAS giving a talk on global warming. ఎవరు చూసినా global warming, atmosphere, what happens to next generation, అవన్నీ మాట్లాడుతున్నారు కదా. What makes the global, why does the global warming come in there? I mean also I was joking with the global warming occurs, the earth will get heated up, when the earth gets heated up, the oceans will expand. They will expand so much that I was joking, Hyderabad will have a beach and Visakhapatnam will be wiped out. So we don't want that one happening. That's how they threaten people. So you will have beach at Hyderabad will be santosham. But what happens is Visakhapatnam and Masilipatam they will all be wiped out and they will do all those business. So they are saying that no, global warming is very important after that. Yenduku global warming vastundi, yenduku heat avutadi మనం చూడాలి. So okay, now we come to that. So this amount of absorption, how much of this radiation is absorbed? Again, let's go back to the basic radiation heat transfer, the basic fundamental. First and foremost, it depends on the nature of the molecule. Whether it is triatomic, polyatomic. For For example, you take some of the refrigerants, for example, refrigerant R12, which we were using in refrigerants earlier, it has got a formula of CCl2F2. And the any atoms ఉన్నాయి 5 atoms ఉన్నాయి. తర్వాత ఇప్పుడు ఇది R22 కూడా 5 CHCl2 దానిలో కూడా 5 ఉన్నాయి. Now they have got ethane based refrigerants, that is HFC 134E అంటాం. దానిలో ఇంకా ఎక్కువ ఉన్నాయి. But it's equivalent to like C2H6 ethane family. దానిలో 8 atoms ఉన్నాయి. So more and more the number of atoms in a molecule, the more will be its absorption capacity. Okay, now first and foremost thing is, if you put most of those gases in the atmosphere, you can say that I am going to attenuate solar radiation. That's not good. We still require some amount of solar radiation, so we don't want many of the artificial multi-atomic molecules to be in the atmosphere. That's it. So it depends upon the nature of the molecule, then it depends upon the wavelength of radiation. It is UV radiation, infrared, or UV. UV so the classes are there, UV1, UV2, and so on. Then the higher the molecular complexity, greater is the radiation absorbed. Put in triatomic like CO2 H2O has got one level, methane has got another level, ethane has got another level, this refrigerants have got another level, higher. So CO2 absorption is taken as one, but other gases are compared. For anything in engineering, what we do is, what is ideal situation? In the class, I always compare the best student. He is capable of getting 100%. How good you are compared to all your gate score is only that. You see, MSET, gate score, everything, you take the best one, and then how you fit in along with the spectrum. So similarly, in radiation absorption, one calculate here, we take CO2 as one. CO2 1 అయితే మిగిలిన మాలిక్యూల్స్ ఎంత రేడియేషన్ అబ్జర్వ్ చేస్తాయి. That is what is called, that is how the so-called global warming potential or GWP is calculated. You would have seen that most of the place they quote what is called a GWP. That is CO2 is taken as one, all the other molecules are compared. కొన్ని మాత్రం ఇచ్చాను. In fact, this data is available for every molecule that you have in chemical engineering. There is a global warming potential that is calculated. What is GWP? Approximated as abbreviated GWP. Carbon dioxide 1, methane is equal to 62. So if you release 1 kilogram of methane into the atmosphere, it is as bad as releasing 62 kilograms of carbon dioxide. It has got so much of absorption capacity. So if you take the nitrous oxide, this is all oxides of nitrogen, they are also greenhouse gases. There is so much. Economic nitrogen oxide. Can you tell me? Nitrites oxides of nitrogen. Oxides of nitrogen, N2O, N2O2, NO2, gold and atmosphere low time. Economic. They don't naturally occur, right? How do you get those things in atmosphere? Any idea? Who? Someone, it is not doesn't occur naturally, but someone is putting it there. Come on, all of you are driving scooters and cars and whatnot. Okay? So the combustion, for combustion you require air. For air has got 78% of air is nitrogen. Okay, when it comes out at higher temperatures, this nitrogen actually can react. Nitrogen, though it's non-reactive, it can react and form oxides of nitrogen. You get all kinds of garbage there. N2O, N2O2, NO2, so all these gases are also greenhouse gases. All of them are greenhouse gases. N2O, similarly N2O2, there is a number there. NO2, there is a number. Look at this, R12, 7,900. So if you release one, మన ఇళ్లలో ఉండే refrigerator ముందంతా R12, this used to be our refrigerant. That's why we got our vegetable preserved, and also we had our ice cream and cold water in summer. But only thing is, in a refrigerator, the amount of refrigerant that is there, if you take your domestic refrigerator, hardly it is not even 100 grams. 100 grams endu bhayapadalanu, but at some point when you are doing it for servicing, that 100 grams is released out into the atmosphere, which is equal to 100 times 7,900 grams of carbon dioxide being released. That means it is 7.9 into 100. So many kilograms of oxygen. That is 7.8 into 100 is 790 kilograms. The moment you leak the refrigerant out of your refrigerator, you are doing a damage of releasing 790 kilograms of oxygen carbon dioxide. That's what it means. And look at this fellow. This is for R22. When air conditioner used to say nowadays no one uses this. It is 4,300. Now the replacement is for R12 134A. And that fellow is there are gas bad as 7,900, but still it's 3,000 or something like that. So people don't want it. That's why most of the people they say air conditioning and refrigerators are the biggest polluters in the atmosphere. Because although it is contained all the time in the refrigerator, there is no danger. The moment you take it for servicing, you are releasing it, that forms the greenhouse gas. So all these gases, they absorb everything. But only one thing you have got to remember, we said they absorb the radiation, but it did not tell you in what wavelength. So each of these gases have got absorption capacity in a particular wavelength. Water vapor has got absorption capacity at a larger wavelength. Carbon dioxide has got absorption capacity wavelength. Remember in the previous slide, I mentioned that it depends upon the wavelength of radiation, nature of molecule, and path length, how much of path and how deep it travels in the atmosphere. Okay, that's all. So wavelength is actually important part. This is where actually we have a small debate going on in the scientific circles. You can't combine everything into 7,000 into carbon dioxide because carbon dioxide once was 7,900. The 7,900 but CaCl2 it may be having absorption at a different wavelength. At that wavelength, carbon dioxide may be transparent. But still you are comparing apples and oranges. So this is happening at one wavelength, this is happening on another wavelength. How can I compare these two? This is a debate. That's actually the question mark which many people are still not answering. The reason for that one is that in order to do that, we have to decide what is the spectral distribution of absorption for each of these gases. Unfortunately, some of the gases have been done. All the other gases, they are not done. So what they are doing, wherever they are not doing, they are like English was saying that you tar everything by the same brush and target. Which cannot be true because each of them has got absorption to different radiation. Okay, that's one part of it. Now we will go back to what is called a radiation shielding. We know that radiation is one of the poorest form of transmitting heat. Conduction is the best. Convection comes second, and the conduction is the best when it is pure metals or thermal conductivity higher. And convection is better because by increasing the velocity and you can improve the convection. Radiation is one of the poorest forms of transferring heat. But at the same time, radiation heat transfer also many times we want to prevent. So what we, for example, in your thermos flask, you got an inner vessel where actually you put the cold water or coffee. You have got an outer vessel, the in between the gap is actually evacuated. That's what is called vacuum flask. In the olden days, we used to have glass flask. You put under stainless steel flask vessel. The double wall money, what are they? Is it double wall? Single wall. Oh, that means not insulated. Okay. Does anyone carry a double wall flask here?
This is a double wall.
Like double wall. It keeps cool for about a few hours there. Yeah, that's right. That's a double wall. That's the first thing. I drew the diagram the other day at a double wall. But double wall radiation is a temperature temperature the radiation transfer. One last time let's assume that there is one infrared plate which is at 500 one infrared plate which is at 300 Kelvin. Last time we calculated this one is at 500 Kelvin which is red, this is a blue which is 300 Kelvin. And the emissivity of each of this, one of them is 8.85, another one is 0.9. The emissivity factor is F1 to the temperature. This is something I explained earlier, that's why I am not going too deep into this. Okay? This is the Q12 into the Q12 into 0.777, then we have 0.2. Here we are calculating per unit area 5.600 to power minus 8, hot temperature for 4 minus cold temperature. 2396 watts per meter square. Okay? దీన్ని ఎట్లా అయినా తగ్గించవచ్చు. ఇప్పుడు మనం చూస్తాం, ఫర్ ఎగ్జాంపుల్ దేర్ ఇస్ ఏ హాట్ సర్ఫేస్, చాలా వేడిగా ఉంటే మధ్యలో ఒక షీట్ ఒకటి పెడితే ది రేడియేషన్ విల్ బి ప్రివెంటెడ్. కామన్ సెన్స్ టెల్స్ మీ దట్ ఇఫ్ యు పుట్ ఎ షీట్ ఇట్ విల్ ప్రివెంట్ ది రేడియేషన్. ఓకే, అదే లైటర్ వీల్ పెళ్ళిళ్ళప్పుడు మధ్యలో బ్రైట్కి బ్రైట్ మధ్య తెర కడతాను, ఏమంటారు సార్ అని? ఇది కట్టాలి, సమ్ క్లాత్ దే హోల్డ్ ఇట్ అని essentially to prevent radiation from don't know what is radiation is what about the radiation shield is nice to see all of them. There's a radiation shield. Then afterwards the radiation should have been there. That's good. Okay. Time back. What do you call that? Because in Hawaiian Samanata,
Terra antam, sir.
They have a cloth, Jelakara the radiation shield is removed. So more or less there is no radiation. So what we can do is, so this is, let's say, I don't know which is water. They try to, but the radiation shield will come out. Okay? So what we do is, if you have 0.9 or 0.8, I put an aluminum copper sheet which is, I make it highly polished on both sides so that emissivity is equal to 0.1. Okay? Now we will calculate radiation. We'll calculate and find out how much it is. Okay? Shall we do that one? First conservation of energy requires radiation. Hard surface is cold surface. Radiation. This shield is only reduce the radiation but can't prevent the radiation. First heat. One నుంచి C రావాలి, C నుంచి 2 పోవాలి. ఇది థర్మోడైనమిక్ నిమిషం కదా, 1 నుంచి ఇంటర్మీడియట్ స్టేట్ నుంచి ఫైనల్ స్టేట్ పోయినట్టు. ఇక్కడ heat transfer has come from hard surface to intermediate surface. I put C as a copper plate. Simply because copper you can polish it, you can get a nice little one. I'm also usually radiation shield I put copper just as an example. Most of the radiation shields are actually made of aluminum, thin foils of aluminum. Like for example, your cakes and cover just aluminum is one of the, because you can polish it very nicely, and also it is light in weight, and also you can make it into thin sheets. Because you can use stainless steel, think it is very heavy. Polishing stainless steel is more difficult, and also it's more expensive. Okay, this is one of the reasons why I use aluminum. But here I am giving as an example of copper because I wanted to use subscript C. I didn't want to use A. I wanted this way, I put it as copper. So it is 0.85, 0.9. Same as what we had before. ఇప్పుడు రేడియేషన్ తగ్గుతుందా లేదా మనం చూస్తాం. మనకి ఏం చేయాలి ఫస్ట్? ఈ రెండు ఇక్కడ క్యాల్కులేట్ చేసినా ఈ రెండింటికి క్యాల్కులేట్ చేయాలి. ఇప్పుడు ఏమవుతుంది ఇక్కడ F12 ఇది F1 to FC ఏమవుతుంది? Epsilon1 is still about 0.85. This Epsilon2 will be 0.1. కదా? ఇప్పుడు ఈ ఫ్యాక్టర్ F12 ఎంత వస్తుంది చూడండి. 1/0.85 plus 1/0.1 minus 1.
0.08.
My God, that's quick as a flash. That's very good. నేను చెప్పారు కదా, చూసినప్పటి కాదు ఇచ్చాను. ఓకే కట్టాం కదా. సో ఇప్పుడు ఈ ఏరియా కట్టి ఇది పాయింట్ 0.777. ఇప్పుడు ఈ టెంపరేచర్ మనకు తెలియదు. 500 అయితే ఈ టెంపరేచర్ keep it floating. Let us call it as Tc power 4 method. Write down the equation. Q1 to C divided by A will be equal to whatever the number that lady gave me. 0.09. 0.08 to 1 times 5.67 to the power minus 5 times 500 power 4 minus Tc power 4. Leave it as Tc power 4. Okay? This number tells you because we don't know this. My whole idea is that we'll do that. Okay, next what we do is next we will calculate whatever heat is coming here. Let's assume that this cannot store any heat and it has got to be transferred by radiation again. Whatever comes from there to here, it has got to go back. Now this will become the hot surface. Compared to this is hotter and this is colder. So here the emissivity is equal to 0.2. 1/0.1 plus 1/0.9 and 1/0.9 minus 1 upgrade the second.
0.0.
Someone is faster than you. Almost the same, nearly the same, right? Nearly the same, but not exactly. Nearly the same. Then what is the difference between them? So multi that is that number. This is so 1 by A. It will be C to 2 A. First actually okay. First we calculate Q1 to C by A. We calculated some, let's say some X x into 500 over 4 minus tc over 4. Okay, let me run x1. Next we calculated q c to 2 by a will be equal to x2 because emissivity factor change everything. So this will be tc over 4 minus 300 over 4. So because when this is radiating, now this temperature is Tc, the other temperature is equal to 300, so that is the number we have. So but conservation of energy requires that what is coming from there should be going out from there. So here it is equal to the x1, x2. So what we have is x1, so the x1 will be equal to 0.089, first thing, 8.98. First thing, 5.98. No. 10 minus 1, 9. That will be pretty close. Second one, ento 5.98 first this, second one. 9.98. Times EC over 4 minus 300 over 4. Okay. Then the EC can represent only one or not, so you should be able to do it. Can you do it? How much is EC? So, people don't know how to do it. Algebra. Go find it now. Okay, I will do the simplification there. So, 500 power 4 minus PC over 4 equal to 0.98, 0.989, 0.983 times DC for 4 minus 300 over 4. She didn't do it just one step at a time. The ratio is different. I mean, you give me the exact ratio. I have taken some number because I approximately. What is the two ratios of F12s? Is it 0.8? 0.885. Did you get 0.885? No, how much is it? First step one, 989, 983. First 989, huh? First 989, yeah. Second is correct. So then the ratio of the 0.0989 divided by 0.0988, 1.003 something like that. And that's 0071. Okay. So that should be equal to 1.007 times PC power 4 minus 1.007 minus 300 power 4. So you DC equal to 1.007. See, one is 500, other is 300. But your 40 allows the commotions. Later, we Matilo and other, we Matilo and other. 40 allows the mistake. So 400 and 460, 470 per hour. This is how much the thermodynamic actually. He talks about that. But all the just it was an example with the model. That's good. Okay. I think I have to give you a treat. Okay? You follow me after the class. ఇంకా ఎవరికైనా ఎంత వచ్చింది? కరెక్ట్గా వచ్చిందా? మిగిలిన వాళ్ళకి Okay, it will come to somewhere around 400 degrees. Okay, the 443.2. Don't worry about it. Don't worry about it. If you have a lot of about 430, 433. Good. Wise people think alike. You get the gem 433. Ante 433. That is the temperature. So if the 500 degrees only, the 300 and somewhere in between. And somewhere in between common sense చెప్తుంది. So your knowledge of radiation will tell you how much exactly it has got. So 433 you can. 433 పెట్టేసి ఇప్పుడు మనం డిస్కస్ దీనిలో 433 పెట్టండి. Okay. This number will be 0.0983 కదా. First thing 0.0983 పెట్టేసి 5.6 is 10 to the power minus 8. 500 power 4 minus 433 power 4. కట్టండి ఎంత వస్తుంది? let's see what happened. What the girls are getting. Yentama?
Watt per meter square.
Okay, right. Okay, as I told, she gets a grade, she gets a trade, she gets a trade. Okay, how much you get? You buy it. Don't worry about this one. 152, 153 అనుకున్నాను. ఎంత తగ్గింది ఇప్పుడు 2096 నుంచి 156. That is less than 10%, less than 10%. That is 90% of the heat is taken out. Okay, now that is what exactly happens here. So by putting one radiation tube, okay, radiation sheet పెడితేనే మనకు more than 90% of the radiation is cut off. ఇప్పుడు 2 పెడితే ఏమవుతుంది? ఇంకా తగ్గుతుంది. 3 పెడితే ఇంకా తగ్గుతుంది. సో యూ కెన్ పుట్ యాజ్ మెనీ రేడియేషన్ షీట్స్ యాజ్ పాసిబుల్. మనకి ఎందుకు బెటర్ అయితే ప్రాక్టికల్ డిఫికల్టీస్ ఒక్కొక్క చోట ఆ షీట్ని అక్కడ పెట్టిన తర్వాత దాన్ని సపోర్ట్ చేయాలి. సపోర్ట్ చేయాలని దాన్ని సపోర్ట్ పెట్టినప్పుడు ఏమవుతుంది? కండక్షన్ ట్రాన్స్ఫర్ వస్తుంది. సో మెనీ ప్రాబ్లమ్స్ విల్ కమ్ దేర్. బట్ దెర్ ఆర్ సమ్ ప్లేసెస్ వేర్ యూ హ్యావ్ టు యూస్ యాజ్ మెనీ షీట్స్ యాజ్ పాసిబుల్. ఎగ్జాంపుల్ ఆఫ్ దట్ వన్ ఈస్ దీంట్లో లిక్విడ్ హైడ్రోజన్ పెట్టాము. లిక్విడ్ హైడ్రోజన్ సమ్వేర్ అబౌట్ 20 డిగ్రీస్ కెల్విన్లో ఈ రాకెట్స్లో లిక్విడ్ ప్రమోషన్ చేసినప్పుడు హైడ్రోజన్ తీసుకెళ్తాం, లిక్విడ్ హైడ్రోజన్ తీసుకెళ్తాం. అది హైడ్రోజన్ ఎవాపరేట్ అయిందంటే మనకు ప్రాబ్లం. అప్పుడు ఏం చేస్తారంటే దీనికి sphere has got a least surface area for your volume that you would have seen. So ఈ బయట this will be, let's say this is created in ambient అనుకున్నాం. ఈ రెండింటికి మధ్య ఏం చేస్తారంటే మల్టిపుల్ లేయర్స్ ఆఫ్ షీట్స్ పెడతారు. So in order to reduce the radiation transfer and that kind of insulation in the cryogenics, it is called a multi-layered insulation. So there are several layers of shields, radiation shields you put, and then that is called multi-layered insulation. దానికి కొంత ఏం చేస్తుంది? there are some standard techniques are there, so many people who do that. ఇక్కడ మనకి important thing is not the question of whether it is copper, aluminum or anything like that. I can use anything. I can use even the plastic film. Nowadays you know that for most of the cars, and of course nowadays it's not permitted, on the glass they used to put a sheet there. That is actually something like a small plastic sheet. So you can stick there. You can put a plastic sheet also there. Nothing. What matters is only the radiative properties are invisible. So they can polish it. If I have a mirror-like finish of a plastic sheet, and then put it in order to do the job. So you put multiple layers of that one, so in order to reduce the radiation heat transfer. So you can see the importance of radiation shielding. Okay, now, okay, understand there any questions on this one? This is all right done, so this is a big thing, yeah? Okay, the final one. Many times what happens is we have a combined heat transfer. Okay, conduction separate, radiation. Many practical situations we have both conduction, convection, and radiation. I will give some examples where it happens there. The law of superposition says that if 100 watts is transmitted by conduction, 150 watts by convection, and 25 watts by radiation, the total radiation is that immediately our మూడింటిని యాడ్ చేస్తే that is what is called law of superposition. ఆ మూడింటిని యాడ్ చేస్తే total heat transfer వస్తుంది. అంటే we can individually calculate conduction transfer, convection transfer and radiation transfer. క్లబ్ చేస్తే మనకు టోటల్ రేడియేషన్ థర్మోడైనమిక్స్ చూసాం కదా, W1, W2, W3 చేస్తే మూడింటిని యాడ్ చేస్తే టోటల్ వర్క్ వస్తుంది. అట్లాగే రేడియేషన్లో కూడా conduction, conduction here, QC is the convection heat transfer, QR is the radiation heat transfer. Total heat transfer is QC per QR, but if the same areas are involved, this is what is called heat flux. And most of the time, in the heat transfer, we do it per unit area. So this is just divided by same area. What are the examples of that one? చాలా మంది చూస్తారు యూజువల్గా పైన గరాజ్ will be running a steam pipe. The steam will be carried at about temperature of 400-500 degrees Celsius. Sometimes these fellows are too lazy and they don't want to spend money. The hot steam will be flowing through that one. అది పుట్టుకుంటే చేయి కాలుతుంది. So 400 degrees Celsius, it is in a room, so it is transmitting by radiation because of the room ambient air and everything is also transmitting heat by convection also. That's one example. The second example is that of course if you insulate that one, then you have a conduction heat transfer from the pipe surface to the outer surface of the insulation. Then you got heat transfer by convection from the outer surface of insulation to the ambient. And then we have got radiation heat transfer from outer surface of insulation to the room also. That may be very small. If you insulate sufficiently, that may be quite small. Second one is radiator under your bonnet. Then heat transfer is both by radiation and convection. Because when you bonnet open this, suddenly you will see that it is quite hot. Yes, under your bonnet, the radiation, the heat transfer from the radiator is both by convection and radiation also. But radiation is quite small there because most of the heat is taken away by the cooling water, whatever it is. More important thing is if you are using an incandescent lamp for your, because nowadays everyone has replaced with the tube lights, and if you replace with the bulb దగ్గర వెళ్తే చాలా హాట్గా ఉంటుంది. Of course, the bulb again the quality is that because of incandescent lamp, the light radiation comes. That's why you are getting illumination on your papers or books or whatever it is. But the infrared radiation, glass is opaque infrared radiation. So heat and the infrared range of radiation local bulb. Because of that one, the air inside the bulb gets heated up. And then because of the air gets heated up, the bulb surface gets heated up. And then the bulb surface transfers heat both by radiation and by convection. Normally you would have seen that whenever you turn off the bulb, they say you wait for some time before the bulb goes out, before you take it out. That's better than put a So there again you have an example of where the heat transfer occurs both by radiation and convection. Okay. Now, for the convection heat transfer, I think Professor has already introduced you what is called convection. Of course, people have run all the examples in the lab. It is a convection heat transfer coefficient times surface temperature minus surrounding. I must say the surface temperature is hotter. So surface temperature minus surroundings. The radiation heat transfer is actually sigma times epsilon surface times T surface power 4 minus T surround is power 4. Only difference is that HC is replaced by this and here this is replaced by 2 temperature difference. Because we know radiation heat transfer is proportional to the 4th power of temperature. This is combined. Next, first I just we will do the divide and rule. So let us consider only the radiation part alone separately. Q is surface again, I am repeating the surface. Now, your radiation heat transfer gets there. Now, rest of it is algebra. A squared minus B squared, what is it equal to?
A plus B.
Very good. So, write it. ఇప్పుడు చెప్పారు కదా a to power of 4 minus b to power of 4 ఎంత? ఇప్పుడు a squared minus b squared is equal to a plus b into a minus b. a to power of 4 minus b to power of 4 ఎట్లా రాస్తారు?
A square plus
minus b squared multiplied a squared plus b squared. Again expand that a squared minus b squared. I can do the same. Yes, that's all I'm asking. So this power 4 minus this power 4 should be equal to this square plus this square into this square minus this square. Correct? అమ్మాయి లాస్ట్ అర్థమైందా మీకు? algebra. No, she is not sure. You are not sure. కాకుండా అది ఇది 9th స్టాండర్డ్ లో చేస్తారమ్మా ఈ మ్యాథమెటిక్స్ మర్చిపోదాం. Okay, then again you expand this one. So this one we need. So now you q by a, q r by a, and replace that one in inability C. ఇవన్నీ ఇక్కడ సబ్స్టిట్యూట్ చేస్తారు. సో again oops. ఇప్పుడు ఏమైంది? దిస్ ఆల్సో T surface minus T surrounding ఇక్కడ ఉంది. T surface is convection లో ఉంది. So what we can do is that ఈ particular substance ఎంత ఈ surface ఇది ఇవన్నీ కలిపేసి let us call that some radiation heat transfer coefficient. This whole thing is this what we call it like convective heat transfer coefficient. That's actually misnomer. It's nothing like a radiation heat transfer coefficient. But for convenience sake, calculate here on the convenience కోసం the radiation heat transfer coefficient is sigma epsilon into so it doesn't make much of a difference. Either you can use one best way is that you use the average surface of this and then divide it by 2. This is the average of surface of the liquid. If they want to take this is 2, ఇక్కడ ఇది రెండు యాడ్ చేస్తే ఇక్కడ 2t surface squared ఉంది. ఇది 2t surface is average అవుతుంది. 2 plus 2 4 times important this solution. This is just make 2 because it is square root ఇక్కడ 1 ఉంది. ఇది రెండు ఒకటైతే ఇది 2 అవుతుంది కదా. 2 surface squared ఇది వచ్చేసి ఇది 1 this plus this will be equivalent to 2 surface. 2 times 2 is 4, 4 times 3 surface for 4. Actually, you can put it as either I am pressing is I take average of this 2 surface and surrounding divided by 2. This is the average temperature multiplied due to the film temperature in convection. The calculate is lab loop. Same thing we do the film temperature here in radiation also. The average surface temperature between the surface and the ambient. So, Q radiation will be HR into T surface minus T surroundings. So, the Q total will be S plus S sub is what exactly. Now, we will approximately calculate it. We will make epsilon surface equal to 1. Okay. Now, the black pipe, I thought you carry hot water at 100 degrees Celsius. 100 degrees Celsius at 373 Kelvin. 373.1 very precise 100 degrees. And the ambient is at 35 degrees. Okay. Average temperature surface minus level will to 100 plus 35 divided by 2. దాన్ని కెల్విన్ కన్వర్ట్ చేస్తే 273.15 plus this number. దీన్ని క్యూబ్ చేసి 4 times the epsilon is equal to 1. ఇది క్యాలిక్యులేట్ చేసి ఎంత వస్తుంది అక్కడ రేడియేషన్ ట్రాన్స్ఫర్. సార్ ఆల్మోస్ట్ ఐఎమ్ డన్ హియర్. This must be last year. This is last slide. Approximately, I wanted to get the feed for the numbers. ఎంత వచ్చింది? Numbers are just you have to feed it to the calculator to get the numbers. That's it. 4 times 5 point. And I put 5.6 and 30 minus 8 multiply. I forgot to bring the attendance issue because when I am coming, the department was open.
I'll take care of it.